Hello, my name is Gregor Simic and I will show you the meshing toolchain in SOLPS-ITER. First I will select a completed case of the CMOD and head to the populate base run. Here we have 4 tabs, divgeo, caret, triang and b2 input files. First I will run divgeo or click to run divgeo, which will run divgeo first outside of SOLPS GUI, but then if you wish you can dock it inside GUI. I will show you shortly as soon as divgeo starts. We will head to caret and triang shortly after this. Okay, see divgeo is running. As you can see, there is click here to dock divgeo. Click, and after some times you will have it inside your SOLPS GUI. Now I will show you only the completed case of the CMOD, in which case I will click open in divgeo and select CMOD. As you can see, everything is more or less completed. So of course, all the necessary steps were made to prepare the divgeo model for this case, but I will go to caret and show you the other widgets. Here is a widget which is composed of several groups of widgets. On the top we have the checkbox group. These are the self-assessment checkboxes which help the user select which steps were already made in this base run. On the right side we have the divgeo model selector. As you can see, this basically shows us all the divgeo files in the current base run. Of course, if we click update dg list, of course we will get the updated list. Here we have buttons to interact with the caret. The caret is run with script caret in SOLPS-ITER scripts. These are the steps of the caret. It basically makes the user easier to run them. First we run caret with this, start caret. These are the steps: prepare, grid, save, choice, convert and store. On the bottom we have the terminal input, yes and no, which are basically, again, basic interactions with the caret script. Yes, no meaning yes, no meaning no. Terminal input is basically whatever the user should give as input to the caret. As you can see, it's here. If I click on prepare, tada, and grid, etc., this will work, etc. I will just skip this part and go to triang. It's here. As you can see, it has a lot of more steps, but it's the same principle. We have the self-assessment checkbox, in which case here everything was made. We start the triang with the start triang. Of course, on the bottom we also had an extra button aside the basic interactive buttons, the edit b2ag.dat file. If we click on it, if the b2ag.dat file exists, we will get the content of it, but at the end we will get the information of the latest SONET file if and only if we have of course edited it, and then of course tells us what to change, so we correct it, and of course which parameter has to be changed. In this case, the first one has to go from -1.0 to -2.0, etc. This is a minor help to the user. Of course, the steps, the uimp, uppercase U, lowercase u, b2ag, etc., etc., etc. And of course, at the end, what it provides, I can show you at the divgeo. First, I will remove everything which is unnecessary for the result to see. If only divgeo will obey me. I will remove the points, the chords, the surfaces, grid points, the mesh, and the details, and the equilibrium, the basic, and only the template basically stand. And I will import. Actually, no, I will show you the equilibrium as well. And now I will import the template, of course, by triang, which is this one. If I load, you can see the meshing in this part, and then of course the other result, which is this. This is basically it. And of course we have the b2 input files, which further populates with the necessary b2 files. In this case we have b2ai, b2ah, b2ar, b2mn. If I click on b2ai, I can see that it already exists, etc. And this is how you use the meshing toolchain in SOLPS GUI. Thank you very much, and bye bye.